All right, welcome to the final exam review for the 2014-15 school season, right? And this is just some basic studying tips for exams and large tests, right? Start early. Don't wait until last minute. Last minute is not the way to fly. Don't study for more than an hour without a break or 2 hours without a break. Get up, drink some water, walk around for a little bit, maybe play a video game or something. Just do something brainless to get a little relaxation and get back into the moment. Use your notes, quizzes, tests that you have to guide you through the review, right? This is not meant to be completed without help. It is not meant to be completed without help, right? This is probably the #1 mistake students make, okay? The only thing we expect you to make it through without help is the exam itself. Onward and upward to question number 1. Okay, so for question number 1, what kind of function does this table represent? Well, let's take a look over here at the differences for our y values. And remember, if we are adding a constant, we have a linear, and if we're going up by a constant multiplier, we have an exponential function. So, looking from 10 to 13, we're going up by 3, and from 13 to 16, we're going up by 3, and from 16 to 19, again, up by 3. So since we're adding a constant, we have a linear function. Okay, and now we want to write an equation. Okay, so if we're going to write an equation, I vote for writing it in slope-intercept form, and I would like to use the point-slope formula. So we have y minus y1 equals m times x minus x1. And what we're required to use the point-slope formula is we're going to need the slope, and we're going to need 1 point, our x1, y1. Well, since we're adding by 3, that is our constant addition, right? So our slope is 3. And if we pick any particular one, so let's just say we use this set of coordinates, then that's 2, 13. So we have y minus y1 is 13 equals 3 times x minus 2. So that's y minus 13 equals 3x minus 6. Add the 13 to both sides, and we get y is equal, for our final answer, 3x plus 7. Now this is our final equation, but let's just check it. If we took an x value of 4 and we placed it in there, 3 times 4 would give us 12, and 12 plus 7 would give us 19, which is the y value. So I feel pretty confident that we have the correct equation. In our second example, we're taking a look at the y values here, and to go from 2 to 10, you either add 8 or multiply by 5. To go from 10 to 50, you obviously don't add 8, you multiply by 5. So we have multiplying by 5, and of course, 50 times 5 is 250, so we have another multiplied by 5. So this function is an exponential function because we are changing by a constant multiplier. And our model equation for exponential equations is y equals ab to the x. And as you notice here, right, a is our initial value, our initial y value was 2, and b is our constant multiple, or otherwise known as, more officially, the growth factor. So we have y equals, our initial value was 2 times 5 raised to the x. Another more formal way to write this would be f of x, right? It's a fancy way of saying y equals 2 times 5 to the x. And then you just want to double check that by putting this into your y equals into your graphing calculator, or just check it by hand. As you see here, I've done the work. I'm checking for this x value of 3 to see if the y value comes out to be 250. So f of x, right, your x value is 3. That means that it's 2 times 5 to the raised to the 3rd power. Exponents first here, so 5 to the 3rd is 125, and 2 times 125 is 250. And up in our table, f of 3 is 250. So that means that my equation right here is good to go. And that's our final answer right there. Moving right along, Jane works as a travel agent. Every week she gets paid $900. That's Jane's base salary. She's always going to get the 900. Of course, I don't think she's going to get 900 for very long if she doesn't start selling some cruises. But anyway, she's also going to get $75 for each cruise that she books. That's her commission. So when we go to write an equation, again, we're going to stick to the slope-intercept form. What we're going to do is just change a few things. I like to keep this in context. So instead of writing Y, I'm going to write a dollar sign because they said they wanted Y to be her pay, and X is going to be the number of cruises. So dollar sign equals, for the slope, that's the additional amount she's going to get for each cruise, or it's that constant addition piece. So the thing that's changing isn't her base salary. The thing that's changing is how much she's getting paid depending on how many cruises she sells. So it's 75 times a cruise plus her base salary. So there's our equation. Now, how much will she make if she books 10 cruises? Okay, so first, this is answer A. Okay, now for B, all we have to do is just put 10 in for the number of cruises. So we have dollar signs equals 75 times 10 plus 900. Whoops. And 75 times 10 is going to be 750 plus the 900. So Jane is going to make $1,650 right, at the end of the week. Not bad for Jane. All right, so we're just going to box that up and label that with, that's part B. Okay, now we need a little room for C, so I'm going to shrink this down a little bit. For part C, it wants to know how many cruises will she have to book to make $2,000. So now we have our dollar amount has been given. So we got 2,000, oops, there's the bell, 75 times the number of cruises plus 900. So this time we're solving for the number of cruises. So the first thing we need to do is subtract 900 from both sides, giving us 1,100 on the left side equals 75C. Now when we divide by 75 on both sides, what we're going to get for an answer is 14.7 approximately cruises. So that means that it's over 14 cruises. So what we're going to say is the number of cruises for part C is going to be about 15 cruises. And the reason I say 15 cruises is 14 cruises will make her less than 2,000. 15 cruises will make her over. Only 14.7, which is not possible, will make her exactly 2,000. So we're going to say about 15 cruises for part C for our final answer. Number 3 has a given function. It's kind of lengthy right here, where X represents the number of hours worked, right? X represents hours worked, and f of X, or Y, represents pay in dollars. So it wants us to find the value of f of 5, or in otherwise, because then we have to explain this in the context, is really, for 5 hours, how many dollars does that represent? Okay, because X represents hours and Y, or f of X, represents dollars. So what do? Wherever we see X, we put in the number 5. My suggestion, there's two ways you could approach this. You could take this whole function here, you can take this function, and you can simplify it up a little bit to make it easier to substitute in values, and that's what I'm going to do first. All right, so as you see, I wrote out just copied the function across, and then I distributed the 4x. Everything else is just the same. 4x plus 12. Then I underlined my like terms and circled the other like terms. So my variable expressions, 2 plus 3 is 5, plus 4 is 9x, 10 and 12 is 22. And now I'm going to evaluate the function for f of 5, and I end up with a value of 67, right? F of X, or f of 5, now is our X value, is going to be 9 times 5, which is 45, plus the 22, which is a final answer of 67 for the interpretation. And here's our interpretation, that 5 hours of work results in $67 of earned pay. That's all. How about the second part? Find f of X equals 112. And what does it mean in the context of the problem? Or find when f of X equals 112. So now we're saying that f of X is worth 112, or wherever I saw f of X, I'm going to put 112. The difference here is f of 5 versus f of x equals 112. So now what I'm going to say is the following. Notice the subtle difference here. 112 went in for the f of x versus before 5 went in for the x, because it's f of 5 replaced the x, versus we're replacing the entire f of x with 112. And now we end up with an x value of 10. So over here we were looking for a y value, right? 5 goes with a y value of 67, or 5 comma 67. And over here we have 10 comma 112. Now for the interpretation, see if you could do it on your own. It doesn't matter the order. You could have said 10 hours of work yields you $112 of earned pay. But I say the 112 first because that's what I knew first. $112 of earned pay comes from 10 hours of work. There we go. The key here is, are you looking for a y value or are you looking for your x value? What have you been given? Part B, you were given the y value. Part A, you were given the x value. Notice in part B, the reason I know I'm looking for y is because I still see the letter x here. Up here, I don't see the letter x, so I must have the x value, f of 5. On this problem, notice I said up at the top here, please do not make an error on this problem in the exam. Why? Because this is a gimme. Right here, we just want to write y equals mx plus b, where b is our y-intercept, so we have a b value of +1. And I'm just carefully checking my scale. I go 1, 2, 3. The first number I see is 3, but it's 3 lines up, so this is a scale of 1. So if I want to find the +1 on my y-intercept, I just go up 1 and make a dot. Now, my slope is -2, 3, so that means I'm going to go down 2 and to the right 3. So I go down 2, 1, 2, and then right 3, it's 1, 2, 3, and there's my 3. And I'm going to make a point right there. And I'm going to connect my points, put arrows on both sides to denote that this is a line. It continues in both directions forever. That's it. Awesome. Easy points. Okay, for this question, we're going to use this equation right here, 2x minus 4y equals 12, to complete the following section. And I've included for you just a little reminder on what x and y-intercepts are. Right, so for right here, the y-intercept is the value of y when x is 0. And the x-intercept is the value of x when y is 0. So let's take a look algebraically how that works out. First, we're going to find the y-intercept. And the y-intercept, again, is the value of y when x is 0. So what I've done is I've put a 0 in for x right here. Now I'm just going to evaluate that. So 2 times 0 is 0, so I get -4y is equal to 12. Divide by -4 on both sides, and I get y is equal to -3. So we're going to be able to plot a point of 0, -3 on our graph later on. I'll sort of box that up. Now go ahead and try to set up the x-intercept and calculate that, then check back in. Okay, so as you see, I wrote 2x minus 4 times 0, because now we're trying to find the value of x when y is 0. So I put the 0 in for y. 2x minus 0 is just 2x, so 2x equals 12. Divide by 2 on both sides, you get x equals 6. So our x-intercept is at 6, 0. Let's plot these now on the graph. What we're going to do is just simply place the values that we have onto the graph. 0, -3 is right there. 6, 0 is right here. Draw the best straight line I can through those 2 points with arrows on both sides to indicate that this line goes on forever in both the left and the right direction. And that's it. There are 2 gyms in Groton advertising promotional plans, and the membership plans are as follows. So you got a $120 one-time membership fee plus $10 per month, and then on Gym B you have a $50 fee, right? It should say one time, it's assumed, and $20 per month. So write the equation for A and B. Again, we're going to be sticking to our plan of slope-intercept form. So this is all about cost, right? So the cost in dollars for Gym A is going to be $10 per month, right? 10 times M for months, plus the $120 one-time fee, that constant. For Gym B, dollars, right? The cost is going to be $20 per month, right? Cost more per month, but that initial fee, that one-time fee, is less. So what's going to happen? I think you can see this one coming a mile away. the cost feature on this one's going to climb faster than our A function here. But at some point, they're going to collide and cost the exact same amount, right? This is a classic systems of equations problem. Okay, so classic system of equations, solving using either substitution or elimination. I believe that substitution is the easiest here because we have both of these equations solved in terms of cost. So wherever I see the cost, right, that dollar amount, wherever I see that in the other equation, I'm going to substitute the 20m plus 50. So we have an initial equation of 20m plus 50 equals 10m, right, for months, plus 120. Subtract our 10m from both sides, and we're left with 10m plus 50 equals 120. And we subtract the 50 from both sides. We get 10m is equal to 70, divide by 10, divide by 10 to isolate. Remember, the goal is to isolate the variable. 7 months, right? M is equal to 7 months. That is the time when both gym memberships are identical costs. So that basically just answered D. And there you have it. At 7 months, right, M, both gym memberships have the same cost, right? And that cost was in terms of US dollars. Which, by the way, was $190. How did I get that? Put 7 in for both M's and evaluate it. 70 plus 120 is 190, and 20 times 7 is 140 plus 50 is 190. There you go. Now we really know that this is the correct piece. 7 months, $190. Written as an ordered pair, 70, 190. All of that is extra information, but that extra information shows me that you truly understand the problem. The final answer for interpreting is simply just this piece. Check with your Algebra 1 teacher to see if you're being held accountable for this problem. This particular problem is exclusively done using the graphing calculator. And the first thing you're going to want to do is going to L1 and L2 and put your data into your calculators. And so the reason I put L1 here is hours spent on the beach, hours or time usually is an independent variable, so that'll be our X list. And therefore the number of pieces of glass found will be a function of X. And so we go into the calculator, stat edit, and put our data in, and then you're going to go to stat, calc, linear regression. I don't know which one you've used. There's 2 options. Follow along with your teacher's guide on that one. And we're going to want to write these answers in slope-intercept form. So you'll either have the linear regression that looks like y equals a plus bx, the statistics favorite, or y equals ax plus b. Now, the critical component here is, in the first one, a is my y-intercept, versus the second one, a is my slope. So that's what I say. Just follow along with whatever one your teacher rolls out with. Let's take a look what the final answer should look like when it's in slope-intercept form. So for an equation, my calculator gave me the number of pieces, right? Your y is pieces of glass found. So the number of pieces of glass found is equal to 0.419 times the number of hours spent on the beach plus 3.33. And when you take a look at that scatter plot and this line on that, it's really not that great. But we're going to use the equation to predict what's going on at 12 hours. How many pieces of glass do you have? So that's set up like this. So I'm just kind of lazy here. I'm just writing number. This is the number of pieces of glass found, right? Because that's what I'm looking for, right? Predict pieces of glass, so that's what we're looking for, times the 12 hours. Okay, or I'm sorry, after 12 hours, what are we going to do? We're going to evaluate the right side. So the number of pieces of glass found is approximately 8.36 pieces of glass. To answer the next question, I'm just going to refer to my equation from the previous slide. The y-intercept, right, to the nearest hundredth is simply going to be 3.33, and that's pieces of glass, right? It's a y value when x is 0. What does that mean? It means at 0 hours on the beach, you will have collected 3.33 pieces of glass, which is impossible. But that's sort of the correction figure that makes the whole model work out. All right, find the slope for your trend line to the nearest hundredth. The slope then, right here, is going to be 0.419, and that's a piece of glass, right? Pieces of glass per hour. Because remember, we're talking about change in rise over change in run, right? Y over X, where Y is glass and X is hours. So that's 0.419 over 1, technically, pieces of glass per hour. All right? Are the data positively correlated or negatively correlated? Meaning, the correlation sign is always the same as the slope. So as time goes on, are you gathering more glass or less glass? Right? Is it going up or is it going down? It's going up because we have a positive slope, and if you look at the picture, we also have a picture where the line is going up. So we have a positive correlated set of data, and the connection is kind of weak. It's not that great. And the reason we know that is that our R value is 0.565 rounded to the nearest thousandth, and that's really not that strong. For our next example, number 8, we're simply going to solve the equation for x, right? We want to get an x equals for a final answer. On number 9, we want an L equals for a final answer. For number 9, we're not going to have a particular value for L. We're just going to have a rearranged formula. For number 8, we'll have something that's solvable. So go ahead, solve it, check it against mine. I came up with a value of negative 18.5 equals x. And the reason I initially chose to subtract 4x from both sides is to keep my x value positive, and I ended up with a negative 18.5. Now, when solving for L, let's see what this is going to work. I'm going to have P is equal to 2 times L plus 2W. Well, if I want to get L by itself, the first thing I need to do is subtract 2W. So I'm going to get negative 2W plus P equals 2L. Now what I'm going to do is divide everybody by 2. So divide that by 2, that by 2, and that by 2. And working from left to right, this is going to give me a negative W plus P divided by 2 equals L. And that's a legitimate final answer. Or I could also just rearrange that and write that as P divided by 2 minus W equals L. Either way, that works. Just be careful to watch your signs and simplify your final answer. As far as testing whether or not a relation is a function, most students are familiar with the vertical line test. So I just want to show you something that fails the vertical line test. So we have these 2 points. And would this pass the vertical line test? No. That line goes through both points. So what was the situation? Well, let's give these points some, quasi-coordinates. So let's call this point right here 2, negative 1. Okay? And up above it, that's going to be what? It has to be the same value of x. So what we notice is that we have the same value of x showing up twice, going to 2 different places. So that's what I look for. Up at the top here, I look across my x values. Do you see any x values that are repeating? You say, no. Then this is definitely a function. This relation is a function. Check. How about on part B? Do you see any x values repeating? And you should say yes. Negative 2 shows up twice. Where does negative 2 go the first time? It goes to 4. And then where does negative 2 go the second time? It goes to 1. And that's what we're going to have. We're going to have points stacked on top of each other. One x value cannot go to 2 different y values. If you see negative 2, it has to say 4 both times or 1 both times. So this one is, I would say, how about this? Not a function. Over here, yes, a function. Over here, not a function. As I go through these problems, I just basically do the same thing. Our x values are a series of states, okay? So do you see any state mentioned more than once? You see Maine, New Hampshire, Vermont, Massachusetts, Rhode Island, Connecticut. Nope, all states are mentioned once. Each one is paired with an actual capital, so I would say that this is, yes, this is a function. Good. All right, over here, I see that 1 is split to 2 different values in the y values, or this would be your input and this would be your output. 1 can't go to 2 different places, so this is not a function. Over here we have 3, 9, and 4. Nobody's going to multiple places, although 9 and 3 both go to the same spot, but that's okay because you would have 1, 2, 3, -9, and then keep going, yada, 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 down to 9, -9. That still passes the vertical line test, so this is a function, okay? And then over here, Tiger Woods goes to golf, Eli Manning goes to football, Serena Williams not going anywhere. She's not being mapped, so this is not going to be a function because not every item in the domain is mapped to something over in the range. So this is not going to be a function. Each element in your domain must be paired with something over in the range to be considered for a function. Okay, so in looking at this situation here, it says fill in the table below. X is the figure number and Y is the number of sticks. So up here, this is figure 1, so I said 1, and I counted the sticks, and there was 6. Figure 2, 2, count the sticks, there's 11. Figure 3, 3, count the sticks, 16. And figure 4, and I went to 21. How did I get 21? Well, the difference of 6 to 11 is adding 5, and the difference to 11 to 16 is adding 5. So when I add 5 to 16, I get 21. So I guess my slope is 5. And the reason it's 5 is because that is my constant change, my constant addition. So slope is 5. I could also go through the process of formally identifying these as coordinates. So off to the left I chose 211 and 316, and I process them in my very formal method of calculating slope. Hey, there's the bell again. All right, and that's that. So the slope is still equal to 5. Okay, so now we want to calculate the y-intercept. Remember that the y-intercept is the value of y, right? What y equals when x equals 0. So looking at our data from the table, we had stage 1, stage 2, stage 3. Stage 1 had a y value of 6, stage 2 had a y value of 11, and then 3 was 16. So if we work our way backwards, right, and sort of build ourselves a little table here, we work our way backwards. When x is 0, we just subtract 5 from y, we get y of 1. So I suppose our b value, or our y-intercept, is equal to, whoops, not 0, but 1. Okay, and now we can write the slope-intercept form of the equation. We said that slope was 5 and b was 1, so y is equal to mx plus b. Use the equation to find the number of, I think this should say, sticks at stage 50. Well, stage was our x value, and sticks is our y value. So the number of sticks at stage 50 is going to be 5 times that stage number plus 1, which is 250, plus 1, which is 251 sticks. And there you have it. Now we shift gears into exponent rules. So A is simply going to be 5 times 3 is 15. And then you have b to the 4th times b to the -2 times b to the -6. And our rule is to add all of those exponents. So 4 plus -2 is 2, plus -6 is b to the -4. And then we can't have a negative exponent, so now we have to evaluate this as b over, or 15 over b to the 4th. That's our final answer. On this next problem here, we have an exponent raised to an exponent, and 2 as an exponent too. It's -2 to the 1st. So that's going to give us -2 to the 1 times 4, which is 4, and then n to the -3 times 4, which is -12. Okay, so we're going to do two things. First, this part right here, a lot of students think that they confuse this with the negative exponent rule. That's just -2 4 times in a row, right? -2 times -2 times -2, which is positive 16 all over n to the positive 12, because that has to go to the denominator because the exponent was negative. That's our final answer here. On C, there's nothing going on with the value of 7, so that's just going to stay 7. And then we have b to the -3 over b to the 7th, which is 7 over b to the 3rd times b to the 7th, which is 7 over b to the 10th. We'll add those. So the first thing I did was dealt with the negative exponent by shifting it into the denominator, and then I added the exponents accordingly. Next, we have k times k to the 5th, which is k to the 6th, all over. And this is 2 to the first power raised to the 3rd, which is 2 to the 1 times 3, or 3. And k to the 6th raised to the 3rd, which is k to the 18th. Okay, so on the bottom, we're going to have 8. That's what 2 times 2 times 2 is. 6 k's on the top, 18 k's on the bottom. That's going to leave us with 12 k's on the bottom. What to do with the top? A placeholder of 1, because everything up top canceled out to become 1. This question part A says, use just the table to tell whether or not the growth is linear or exponential. And so as you look down the sides here, 8 to 8.64 is 0.64. And if you add 0.64 to 0.64, you don't get 0.33. And if you add 0.64 to 0.33, you don't get 0.08, right, as you're moving on onward and upward. So this is, right, it's not a constant addition, right? The growth is not a constant addition piece. It's a constant multiplier. So it's exponential. It's also exponential because of the 8% growth. And how did I get those numbers, by the way? I took my 8 centimeters and I multiplied by 1.08, which is 108%, and I got 8.64. Then I took 8.64 and I multiplied by 1.08, 108% again, and I got 9.33 centimeters and so on. That's how I got those values. Since this is exponential then, my equation is going to look like y equals a times b to the x, where a is my initial value again from that screen earlier on, and b is my constant ratio. So length, right, is my y value, is equal to the original length times, and now this is the tricky part, it's going to be times 1.08 raised to the x, right? Because the rate of growth is 108%. It's the additional 8 plus the original 100% that we had to begin with. If you want to check that, go ahead and substitute in the value of 3 into your x value, and then raise 1.08 to the 3rd, multiply that point times 8, and you'll get approximately 10.08, or 10.077696. But that's the equation. That about wraps it up here for the original portion of the review. Make a second video on the last little extra questions. Hopefully this was helpful. Good luck on your exam, and remember, if you needed me for every single questionnaire, then you need to do this review again on your own to make sure that you truly know what you're doing.